Hello everyone. Have you ever wondered why you feel lighter on the moon than on Earth? Or why astronauts seem to float in space even though they still have mass? The answer to all these questions lies in a very important physics concept called weight. Today we are going to understand what weight is, how it is different from mass, its formula, units, properties, and real-life applications. So let's begin today's lecture. Introduction to weight. Weight is a familiar concept in our daily life. We often say things like this bag is heavy, or this object weighs 10 kilograms. But in physics, weight has a very specific meaning. Weight is related to gravity and depends on where an object is located. Understanding weight is extremely important because it helps us explain motion, balance, gravity, space science, and even everyday activities like lifting, walking, and standing. Definition of weight. Weight is defined as the gravitational force acting on a body due to the Earth or any other celestial object. In simple words, weight is the force with which the Earth pulls an object toward its center. Because weight is a force, it depends on gravity. If gravity changes, weight also changes. Weight as a force quantity. Weight is a force, and therefore, it has both magnitude and direction. It is a vector quantity. The direction of weight is always towards the center of the Earth. This is why objects fall downward when dropped. Formula of weight. Weight is mathematically expressed as weight equals mass times acceleration due to gravity, where W equals weight m equals mass of the object g equals acceleration due to gravity on Earth. The value of g is approximately 9.8 meters per square second. SI unit of weight. Since weight is a force, its SI unit is Newton, N. If an object has a mass of 1 kilogram, its weight on Earth is. This clearly shows that kilogram is a unit of mass, not weight. Dependence of weight on gravity. One of the most important properties of weight is that it depends on gravity. On Earth, gravity is strong. Weight is more. On the moon, gravity is weaker. Weight is less. In space, gravity is very small. Weight is nearly zero. For example, if a person weighs 600 N on Earth, the same person will weigh about 100 N on the moon, because the moon's gravity is nearly 1/6 of Earth's gravity. Mass versus weight. Mass and weight are often confused, but they are very different. Mass, amount of matter in a body, remains constant everywhere. Scalar quantity. SI unit. Kilogram, kg. Weight, gravitational force on a body, changes with gravity. Vector quantity. SI unit. Newton, N. Mass never changes, but weight changes depending on location. Weight in different situations. Weight on the moon. The moon has much less gravity than Earth. Therefore, objects weigh much less on the moon. This is why astronauts can jump very high on the moon. Weight in space. Weightlessness. In space, astronauts experience weightlessness. This does not mean gravity is zero, but the astronauts are in continuous free fall along with their spacecraft. As a result, they feel no weight and appear to float. Measurement of weight. Weight is measured using spring balance electronic weighing machines. These devices measure the force exerted by gravity on the object. Unlike mass, weight measurement depends on gravity. Effects of weight in daily life. Weight affects many aspects of daily life. Walking and standing depend on body weight. Heavy vehicles require stronger brakes. Buildings are designed considering weight. Load. Weight determines how easily objects fall or can be lifted without weight. Many everyday activities would not be possible. Weight and Newton's laws. Weight plays an important role in Newton's laws of motion. It provides the force that causes objects to fall. It affects friction between surfaces. It influences acceleration and motion. Thus, weight is a key force in classical mechanics. Common misconceptions about weight. 16 to 17 minutes. Many people think kilogram is a unit of weight. Weight and mass are the same. Astronauts have no mass in space. In reality, kilogram is a unit of mass. Weight depends on gravity. Astronauts still have mass, but feel weightless. Importance of weight in science and engineering. Weight is crucial in structural engineering, aviation, and aerospace science, sports and biomechanics, space exploration, physics experiments. Engineers must calculate weight accurately to ensure safety and efficiency. Summary and conclusion. To summarize, weight is the gravitational force acting on a body. It depends on mass and gravity. It is a vector quantity. Its SI unit is Newton. Weight changes with location. Understanding weight helps us understand gravity, motion, and many real-world phenomena. Call to action. If this lecture helped you understand weight clearly, like the video, share it with your friends, subscribe to the channel for more easy and concept-based physics lectures. See you in the next video.